Hi Year 12 Maths General students. This lesson is from Unit 3 of the Queensland Maths General syllabus, and we're looking at mean smoothing time series plots using Excel and trendline forecasting. So in a previous lesson we looked at how some of the time series data fluctuates quite a bit. So the lesson objectives today are we're going to look at how we can smooth that time series data using something called moving averages, and we're going to use Excel to do that. We're going to look at the differences between odd and even mean smoothing and plot raw and smooth time series data onto Excel graphs so you can see the effect of smoothing. And lastly, we're going to fit least squares regression lines to the smooth data to use in trendline forecasting. In our last lesson, we had this example with temperatures, and you can see that there's a large number of fluctuations there within the data. And this is reflected by when we fit a trend line, we get an R² value of essentially 5%. It's not a very good correlation between the points and the trend line. So we're going to look at a smoothing process we can use to create a better view on the trend that's happening with the data. So we're going to use a technique called mean smoothing or point moving averages, and we utilize our skills on averaging a set of numbers, and this can be done with an odd or even number of points selected from the raw data, and those averages will smooth out irregular fluctuations and make any trends much more apparent. We're going to start off with odd mean smoothing, and for the purposes of this lesson we're focusing on 3 mean smoothing and 5 mean smoothing. So essentially, to smooth out the data, you use an average of 3 sequential result values, okay, and we call our smoothed point yn, and the general formula is these are sequential values from your results table, so centralized on the value that you're after, and then you take the value before and the value after, then dividing by the fact that there's 3 values. For 5 mean smoothing, you're simply selecting 5 sequential result values. So focusing on your smoothed point, you'll grab the 2 values before and the 2 values after and average 5 values. Essentially, the larger the number of points we smooth over, so the larger the number of values you average, the greater the smoothing effect. So if you used a 7, a 9 or an 11, you would get even more smoothing effect. For the purposes of this lesson, we're not going to do this manually by hand. We're going to use Excel to help us do this because obviously that's going to be a much quicker process. So we're just using that average command in Excel and selecting the relevant number of cells to find our yn. So to help understand how those formula work, we'll just get stuck straight into the example. Looking at A, it says using Excel, calculate the 3 mean smooth temperature for Tuesday of week 1. So here's Tuesday of week 1, and we want the 3 mean smooth temperature. So centralizing around the Tuesday, we'll select these 3 values. Squidging in part of our formula there, that means our Tuesday is the yn, the Monday is the yn minus 1, and the Wednesday is the yn plus 1. Okay, just talking through B, we're going to use Excel again, but just so you know what values we're targeting, we want the 5 mean smooth temperature for Thursday of week 2. So here's Thursday, so I'm going to select it, and the 2 numbers either side. To make up the 5 numbers, I need to average for my 5 mean smooth temperature for Thursday. Yn's my centralized point that I'm smoothing, and Wednesday's the yn minus 1, Tuesday's the yn minus 2, Friday's the yn plus 1, Saturday's the yn plus 2. Okay, enough of the theoretical, let's get practical with Excel. Okay, so you should recognize this from the last lesson. And all we're going to do is underneath the main raw data, we're going to put our 3 mean and our 5 mean smoothing under there. I'm just going to move this out of the way for now. Okay, so we want our 3 mean for Tuesday of week 1, and we want our 5 mean for Thursday. Okay, so demonstrating how the formula works, the cell underneath the point that you're smoothing, just essentially enter in your formula, average, and then select the cells that you want the average to be calculated. Press enter, and it pops out the value for you. So we've successfully smoothed out our Tuesday of week 1. For the Thursday, we want the 5 mean. So we'll select the 2 values either side of Thursday. Press enter, and there we go. We've smoothed out those 2 points. Just before I document my answer, I'm just going to format my cells to round to 1 decimal place. Alright, just popping back to document my answers. We've got a 3 mean smooth temperature for Tuesday in week 1 of 28.3 degrees Celsius, and a 5 mean smooth temperature for Thursday of week 2 of 25.6 degrees Celsius. And this would be the working I would show if I did it manually by hand. And we're going to head back to Excel to finish off C and D. I'm going to show you how to very quickly calculate the rest of the 3 and 5 smoothed values, correct to 1 decimal place for the rest of the data. Okay, so we start off by selecting the cell that we want to copy this formula across the rest of the row of the raw data. So it will calculate the 3 mean average for each of these. Excel will just recognize that. And you'll notice that I only extend it to Monday and in week 3 Friday, because this highlights the limitation with using mean smoothing. We can't average the end raw data because we don't have the consecutive day after. So Friday's the limit. So if I look at Friday, I can use the 3 mean smoothing. Saturday, I don't have Sunday to average that value. Do the same with my 5 mean. Again, being careful to consider that Thursday's the last day I can use a 5 mean smooth. Extend it back the other way to Tuesday will be the last place I can use the 5 mean smoothing. And we're done. You'll also notice these little green triangles, and this is Excel trying to tell us that we've potentially made an error. If you hover over the exclamation mark, it tells you what it thinks the error is. So it wants us to include Sunday in the formula range, but we can't do that. So to make that go away, you just click on the error and tell it to ignore it. Now, even though this particular example question doesn't ask us to do it, I just want to give you some sort of insight into the effect of mean smoothing. So I'm not going to tidy this graph up or polish it, just in a really raw form. You'll notice here the blue is the raw data. You can see that the 3 means has smoothed it in the orange, and the 5 mean smoothing has smoothed it even more in the grey. So if we need to down the track, this will help us produce a more reliable trend line. And in particular, when we're dealing with this outlier, you can see that it smooths out where that outlier occurs, particularly in the 5 mean smoothing. If I take out that outlier, you can see that it smooths the plots even more. I'll put that one back in there. Then I just need to make sure that I document my answer. Moving on to looking at even mean smoothing with centering. It's a similar process to the odd numbered mean smoothing. However, in this process, we're doing essentially 2 lots of averaging. So whatever point you're focusing on, your yn, you take it and the value before it, and you average that. You take the value you're focusing on and the value after it and average that. And I kind of call these like your first half and your second half of your smooth point. Then finally, to focus back onto your smooth point, you take the average of those 2 values that you've found previously. And a very similar process for 4 mean smoothing, where the value you're focusing on, you take 2 to the left, 1 to the right to find a first half of an average. Then you take 1 to the left and 2 to the right to take the second half, and then you average those 2 averages. So in Excel, this one's a little bit more complicated. So essentially, because we're doing an average of averages, we set up our cell command to look like that. It's going to be so much easier when we actually do an example, so you can visualize what we're saying here. So let's do that. Part A asks us to do the 2 mean smooth temperature for Tuesday of week 3. So there's Tuesday of week 3. Alright, so with 2 mean smoothing, because Tuesday is our central, we need to find the average of Tuesday and Monday, our yn plus our yn minus 1 over 2. And then we need to move on to finding the average between Tuesday and Wednesday, our yn and our yn plus 1. Once we've found those values, then we find the average of those, and we end up with our smooth point for yn. For part B, we're focusing on Thursday of week 2. So to calculate that mean smooth point, we take 2 values to the left and 1 to the right. So there's our 4 values we're selecting. And for the second half of the averaging, we take 1 value to the left and the 2 values to the right. So once we find the averages of those 2 sets, then we have our 4 mean smooth temperature of yn. Okay, let's do this in Excel. So I've just popped in the new information that we're chasing here. Okay, so for part A, we want the 2 mean smoothed here. This is where we got to put the average within the average calculations. So we want the average of our first half. And so you can see that's pale blue. And then we want the average of our second half. Don't forget the extra closed brackets. So this outside one will average the averages found of the inside ones. And that gives you my 2 mean smoothed average for Tuesday in week 3. Okay, if I do the Thursday one, same formula, except I'm just selecting more cells this time. So I want the average of my average of the first half, comma, my second half, close brackets. Okay, so my 4 mean smooth point for Thursday in week 2 is 25.5 degrees Celsius. First part C and D, they want us to continue for the rest of the data. So same process as before, select the cell, grab the little green, and consider where I can take a 4 mean smoothing to. So Thursday of week 3. And then I can take it to Tuesday of week 1. The 2 mean smoothing, I can take that to Friday week 3, all the way down to Monday of week 1. The last thing we need to do is to reformat the cells to consider the number of decimal places we're seeing. We want to round it to 1 decimal place, so if I right click on that and go to Format Cells, I can then, let's do it to 1 decimal place, round it to that. And if you see this hash, just move the width of the column over and that'll fix it for us. So we can see Tuesday's smooth mean is 23.5 degrees Celsius and Thursday's is 25.5. Okay, so I've just documented the results there. And you can see that I've also shown you how to manually calculate those averages using the formula we looked at earlier. In this last part of the question, we want to finalize what we're seeing with the raw data compared to the smooth data. So I'm just going to choose to work on the 3 mean smoothed averages. And we're going to comment on the observations made from the plot in terms of any trends present. Fit a regression line to both the raw and the smoothed. And we're just going to look at the differences between the two. And then we're going to play around with deleting the outlier and seeing how it affects the trend line and coefficient of determination. I'm going to start with a new graph, so I'm just going to get rid of this one. And because I'm interested in the 3 mean, smoothed, and the raw, I just select all 3 rows and insert as we have done previously, align with markers chart. Make sure you add in your title and your axes. And then we'll pop those trend lines in. So I'm going to do the raw data first. And the 3 mean smoothed next. And you'll notice that I've color coded it so I don't get the 2 mixed up. Before we move on, I just want to show you how all of these compare in terms of smoothing. So I'm just going to move this graph out of the way and we'll just quickly create a really raw version of all of them. Just going to change the scale so we can zoom in a little bit. Okay, so if we look closely, and it just shows you that the more points you pick to average, the better the smoothing effect is for your time series graph. So if you look at the 2 in yellow, 3 in orange, 4 in blue, and 5 in grey, the 5 mean smoothing is the most effective at smoothing out those fluctuations within the time series plot. Okay, so just bringing that graph over to now answer the questions. So we've plot our raw data and the 3 mean smooth average. We need to now comment on observations made from this plot in terms of any trends present. So if we look closely for the trend, we can visually see that it's a negative linear trend, and our gradients, both of them support that because they have a negative value. For C, I have already fit the least regression line to both of them, and we can see the equations and coefficient of determinations displayed underneath there. In terms of comments for any of the differences that we're seeing there between the two, well, firstly, I'm going to pick the y-intercepts. They're both similar in value, so they're both around 26.8. You can visually see that the 3 mean smooth line gradient has reduced that effect of the outlier, so it's smoothed it a little bit more, and the gradient, if you compare them, is a little bit smaller, so it's a less steep negative gradient. If I'm comparing the coefficients of determination, the raw data only has about 5% correlation between the data points and the regression line, where the smoothed data has increased to nearly 11%. I mean, that's still not great, but it's better than it was. Part B wants us to trial deleting the outlier, and I demonstrated how to do that before on Excel. And then just comment on the effects this makes to the trend line and coefficient of determination. So if we scroll down and have a closer look to compare the two, let's have a look at the trend line changes. So without the outlier, the y-intercepts both increase to around 28.5 degrees Celsius, and the slope value steepens. So they're still negative, but you can see that both gradients are a higher value, so it steepens the gradient. Looking at it, the most obvious difference is the increase in the coefficient of determination for both the raw data and the 3 mean smoothed. So the raw goes from around 5% up to 27%, and the smooth goes from around 11% to around 64%. So that increase in correlation would increase the reliability of this regression line equation to more accurately model what's happening with the data over time. Lastly, for this lesson, we're going to look at using trendline forecasting to make predictions. So essentially, this is the same as when we're extrapolating with other bivariate data, where we would compose a model using your least squares regression, and then using that model equation to help make predictions on future values. This is trendline forecasting. We're going to work through the following example, which we've not done before, to look into trendline forecasting. So we've got a table on the number of births per month over a calendar year in a country hospital. And you've been given the raw number of births there. And I've included a spreadsheet that you can access with that data in it already. If you don't have that, then you can just do it from scratch. So the question's asking us to plot the raw data, describe the time series plot by identifying any features such as trends, fluctuations, seasonality, cycles, or outliers. Then we've got to use Excel to calculate 5-point moving averages to one decimal place. Moving on from there, we've then got to plot those 5-point moving average values. and fit a least squares regression line to the data for that 5-point moving averages, and write down the model equation and coefficient of determination, and also comment on the trend observed. Finally, using the trend line established, predict the average number of births expected in August of the following year. So that's where our trend line forecasting kicks in. All right, let's go over to Excel. Okay, so using the raw data, you should compose a table something like that. We want the 5 mean, so we need to make sure that when we select 5 values, we're starting from the central value. We'll use the average, select your 5 values, and then drag it down. Easy peasy lemon squeezy. Let's get rid of that error and put together our line plot. Make sure you make it look nice and pretty and polished with your title and labeled axes. And before I whack a trend line in, you can see that just by looking at the raw data itself, it's really difficult to picture whether there's an increasing trend or a decreasing trend. Once I pop in that 5 mean smoothing average, it becomes a bit clearer that it looks like there's a negative trend. Okay, and let's see if we can confirm that by adding in our trend line. All right, so yes, it is a negative trend because our gradient value is negative. Answering the questions from the raw data, as I said, it's really hard to tell. It looks flat. The only time you can see a more obvious trend is when you pop in that 5-point moving averages, and that looks like a negative trend. And then as soon as we add that equation, we confirm that. There's plenty of regular fluctuations going on in that raw data. May was a busy month for babies, and there doesn't appear to be any seasonality cycles or outliers. Seasonality, there's no recurring up and down pattern within the year, and cycles, we need more than a year to see if there's a pattern there. For C, I've just copied over the table with our 5-point moving averages included. C and D, that's included in the graph. If I put that equation in terms of the response and explanatory variable, the number of births is going to be equal to negative 0.331 times the number of months plus 13.876. For the last part of the question, we're using the trend line we've established, so we're using that least squares model equation. It says we want to predict the average number of births in August of the following year. So if I consider that that whole year is 12 months, then that means August in the following year is 8 months in. So altogether, we're looking for the 20th month. So I want to find the number of births when time is 20 months. Okay, so if I substitute that 20 months into my equation, calculate it, get 7.256 births. Because you can't have 0.256 of a birth, you got to round that down to around 7 births would be expected next August. Okay, that's it for this lesson. For those that have access to my class notes, I'll summarize those Excel steps for you so you can scroll down and check those out. I hope this has helped explain what mean smoothing is. a technique that we use to help smooth out the fluctuations that we see in everyday real life data in order to develop models that more accurately predict future values. Thanks, Year 12s.